Well, good morning. Thought might take a quick look at some HP test gear that I managed to score in an auction from the Department of Defense. Got several pieces, so we'll split this over a couple of different videos and we'll go have a look at them. So the first one that I got is this guy here, and what you can see here is a HP 1120A 500 megahertz active probe. Let's zoom in a little bit and you can see the front of it there. This probe is designed to be powered, and you can see if we look over here that we have a little probe power socket on it, and it's meant to come into a standard oscilloscope, but it's expecting 50 ohms, so I have a little termination item that I'm going to be used there. So let's just zoom out a little bit more and take a look at the item in toto. We'll lay it out. You can see the power comes in here. Now the whole thing is actually designed to be mounted on the side of a scope, and so you mount this into the side of the scope where the heat sink, the airframe is, and then this gives you a little place for you to clip your probes into, and then you can take the probe out and go use it. So these little parts here just simply slide off, and what I'm going to do is I think I'm going to have, I'll keep them because you never know when I might get an old HP scope that utilizes the parts, but I don't really need them for what I wanted to do. Now, the reason I got this was that I was doing some investigation into a problem I was having with my 8657B signal generator, and on one of the pins it said go have a look at a particular waveform, and it told me that I had to use a powered or an active probe to it to get that waveform, and that was the suggested way to do it, because in general active probes will place far less load on the circuit that you're probing, and you can see this quite often. You'll see a little graph and it'll show that for eventually when you get to a certain frequency, the active probes will give you a better apparent impedance for the probe, and let you go look at it. So to run this I needed a couple of other things. Now the first little bits that I needed were these guys here, and the guy that was selling them on eBay, I got this in a Department of, I got this in an eBay auction, and I got some of my other gear in a Department of Defense auction, but so these are all on eBay, and these things are basically a little tip that's designed to plug in over the top of the probe here and to divide the probe by a certain amount. So this tip here is a 10-to-1 probe, and basically what this tip will do is it will go through and divide, and if we get in there, let's see if we can zoom in and maybe get a better view of that part number there. This little tip is designed to actually just plug in on the top of that, and it'll divide the signal by a ratio of 10-to-1, and then I have as you can see here, I have some 100-to-1 tips, and they're fundamentally the same type of tip as you can see there as this guy. So to use this, I just plug this on here, and then HP has this thing they call, I believe it's called a walking tip, and basically it is a very short path tip, so for ground connection. So if I slide that on here, now I have the probe, and then I have my ground connection here, and I can get in and get quite accurate probing. You might not have seen that. Let me zoom back out a little bit so that you can see that. So that's the walking tip probe there. You might have seen it. I don't know if I have probe sitting out, but you've probably seen it in your probes for the passive probes that you might see, where you take this off and you usually get a little, like that's the ground lead there, but you can also take that off, and then you get a tiny little spring basically that clips over that ground point, and that gives you a very short ground path in your probe while you're actually doing the underlying probing. And that's the sort of concept that they've got going on here with this little walking probe tip there. So that's to make it work, but you know, the scope I have is in fact a Rigol, it's a DS 1054. So I don't have scope power on this, especially not the HP version. So to go and do that, what I needed to do was to buy another little HP item, and this is a probe power supply. And so if we bring it in there, let's see if I can get some better light in on that. Oh, we don't know, maybe over there, there we go. You can see this is a probe power supply, and basically this guy, all it does is deliver 4 sets of power for 4 different sets of probes, and turn it on. Now the casing is very familiar. It's that same case that you've seen if you looked at my video on the 461A. Somebody's gone in here and they've taped over all of the little silver stuff that you would normally expect. If you hang on a sec, let me grab my 461A. And you can see and compare the difference here. You know, it's basically the same frame, but somebody for some reason has gone in and taped over the silver linings there. So I don't know what they were trying to do. Was there a glare problem or something that they wanted to fix? But HP basically used that same thing. So I've got a bunch of goof off, goopy gone, or one of those type of things. So I'm just going to be able to go through and remove all of that tape, and then hopefully clean up those surfaces, and you know, make it a cleaner and more usable thing. So let me go do that, and then we'll take a look at it in operation. Okay, so it turns out that there's a bit of tape stuck in under there, so I'm going to actually do a little teardown of this. So let's zoom out a bit so that you can see as much as you can see, because I want to get in and open up that piece of the case to get this tape out. It's like that tape that they use to strap athletes' feet up. It's like a zinc oxide type of tape. Screw is a little stripped. HP, if I haven't said this before, use these posi drive screws, and you can see. Let's see if we can zoom in, and you can see what the posi drive screw looks like. You know, basically, it's got an additional set of little crosses that you might be able to see there, and that indicates that it's this posi drive screw, and so the screwdriver has like a different set of flutes in there to help you get a better turn on it. You know, so whenever you've got those, you should actually be using the right screws to get that stuff open. So there we have a look in one side. You can see we've got the power supply in there, and that. So let's take the top off here and have another look in. Zoom back out so we can see this. Let's see if we can get this to slide off. It really doesn't want to slide off. There's an awful lot of gunk in here. Let me see if I can get... Oh. Nope, okay. Let's take the other side off. And then what we may have to do is, these are actually part of the frame. If you have a look on the side here, you can see that this is actually all part of the single cast aluminium frame there. So we may have to take the frame off one side to clear up that that section that will then let us get in and clean up what's going on in here. Now, I have not read the theory of operation of this item here, but we can see in here, you know, some enormous electrolytic capacitors. You can see that hand-traced, hand-taped sort of board. Let's see if we can get right in there. You can see some of the, some of the little wiggles that appear in the. Let me get my spudgy pointer out. Some of the wiggles that appear in the line based on how it's been taped out to create the etching stuff on it. So that's all very interesting, but I want to try and get this top off. So which side's probably going to be easier for me? That's 1, 2 items there. I think probably this side here. So let's just jump in and take out those screws. A little tip to designers out there. If one thing I absolutely wish you would do when you go build equipment is to use the one set of screws so that I'm not, oh, those don't look like they're, I guess they're binding it somewhere, but use the one set of screws so that, you know, I don't have, you know, or at least minimize the differences in lengths of the screws so that, you know, I'm not dealing with multiple different lengths of screws as I'm trying to oh, there we go. Oh, I see. Oh, okay. There were bolts on the other end of that that thing there, and that's sort of why it's doing that. So let's, now that we've got that, that should give me enough space to get that lid out. And now we can take a little look inside. You can see the nuts there. Hopefully I haven't gone too far on those. I should have a little, there we go. Having a little screwdriver like this really does help getting into spanner like this helps you tighten those things up. But here we can see the board, you know, and we can get in now and clean that tape off in here. But you can see basically the board, it's a fairly straightforward device. It's bringing power in, stepping it down through the transformer, some regulator, some filtering capacitors in there, and then a bunch of little, a bunch of transistors in the TO92 packages that will help bring the individual power. Because if you look at the power supply that's actually on the probe, that power supply has 3 pins on it. So we're getting, you know, what must be a plus, a minus, and a ground, I imagine, or maybe we're getting, you know, 2 voltages. But anyway, that's given me enough space in there to now get in and start to clean this this unit up. So let me do that cleaning up, and we'll come back and have a look at it in operation. So this is interesting. When I was cleaning, while I was cleaning this up, I noticed, and if we zoom in, we might be able to get a better view of this, that these 3 jumpers were disconnected for some reason, and I wonder where those 3 items actually go. So what I think we're going to have to do is see if I can find a service manual for this guy and track through what they're actually expecting. Okay, so it looks like they are related to the power panels here. And interestingly, normally the pins, if we have a look, normally the pins on the board, and we'll see if we can get in there and you can see the numbers that are written on there, 297. Normally those actually are a pin number, but in this particular case, it looks like they're actually the colors of the wires that are expected to hit those pins, because we have duplicated numbers over here that actually do different things. This 7 here travels over to this purple wire, which is over here. There we can see it, this purple wire, which is over here. And let's zoom out a little bit because it's a little less important. Actually travels over to here to this capacitor, and this purple wire here travels through and comes into the purple wires that are connected to the connectors on the front there. So that's actually the first time I've seen that. Oops, that's actually the first time I've seen that, where they've got the wire colors denoted as the pins instead of the actual pins itself. Normally what you see in a HP manual is you'll see like it'll say pin 7, you know, on there, and then they'll give you a set of brackets, and inside the brackets then they'll give you like the resistor color code thing. So that might say pin 1, and then the brackets next to the wire would say 90, which would tell me that it's going to be white and black. Anyway, I've cleaned off the rest of the covers and put that together, so let's put this back together. Okay, there we go. So we've cleaned that up a little bit. We've got rid of the tape around the sides, given the surface a little wipe down with a little bit of isopropyl alcohol. Hook that back up. So now it's time to plug it in and see what happens. Okay, so here we have it all ready to be hooked up. Because it's expected to be 50 hertz, I have a 50 hertz feed through terminator on there, and we'll feed that into my DS1054Z. Now, I don't have a handy signal for it to actually go and divide right now, or to go and probe. So what I'm just going to do is I'm just going to take a feed out of my signal generator. Oh, my little, there we go, the mini grabbers just sticking. Alright, so now I've got a signal source set up, and so now I can plug in the power, and I can turn on the power. And over here on the screen, you'll actually see the power there. Now, one of the cool things about these active probes is that they often come with an offset capability. Now, the offset capability lets you move the signal up and down. And the reason you might want to do that is, let me go and say set a 2-volt offset here. You know. Let's see. So, so you'll see that the signal is now starting to go off the scope. Well, that 2 volts not terribly much. Let's try a larger one. Let's try a 10 volt offset. Oh well, 7.5 is the most that I can put in. But you can see that it's off the screen. Now, typically, I could go and move the position, and bring this guy back down and do all that sort of stuff. But what I can actually do here is I can come in and set the offset. And now, am I turning this the right way? There we go. I can bring the offset back in, and that will let me bring the entire signal once again back down into the center. So I'm effectively able to null out the DC offsets that I might be getting, which is great when you're looking at a bunch of these discrete component systems, because you'll often have DC bias voltages and things like that. And it lets me keep, basically keeps the best resolution I can on the signal in the center of the screen there. So that seems to be a pretty good score. I have, you can see down here, 5.1 volts. I'm having a 5 volt out here. I have it set as my 10-to-1 divider, and if I look at channel 1, you can see the probe is at 10-to-1. If I actually went in and let's go and change that a little bit. Let's go stick a 100-to-1 divider on there. And let me go and cancel the offset here. Let's turn the offset here. And if I step up the scale a little bit, you'll see that I'm able to get, and if I set my probe for 100 times, I'm getting my 5.2 volts. So the basic bandwidth of the 1120 is half a volt, and with the 10-to-1 divider, what I can do is I can get to plus or minus 5 volts. With the 101 divider, I can get to plus or minus sort of 50 volts, and I can have up to a 300 volt offset that I'm trying to read. So overall, these were very inexpensive. This is quite a cheap way for you to get a active probe. I didn't need to have active probe support in my scope. The power supply was worth about $30, and the probe was worth about $20. And I paid 10-ish for the probes. Anyway, I hope you found that interesting. Catch you later. Bye.